So we're going to take a look at dividing polynomials. And the first thing I want you to think about is a simple rule. Think of long division with numerical values and apply the same rules there. So let's start with a simple example with long division and see to ourselves, okay, these same rules are going to apply. So let's say you're asked to divide the number 41 divided by 7. Clearly 7 does not go into 41 evenly, but what we can do here is we can write this as a long division example. So 7 into 41. 7 doesn't go into 4, so there's really a 0 here. Okay, there's nothing there. But 7 goes into 41 how many times? Well, it goes in 5 times. So 0 doesn't even need to really be here. 5 times 7 is 35. And then when we subtract that from 41, we're going to have it 6, which means 5 remainder 6. And if you remember, this 6 is really the fractional part of the mixed number. So this is really 5 and 6/7. And again, how do we know this? This 5 here, the quotient, becomes the numerical part or the whole number part of the mixed fraction. The remainder becomes what's left in the numerator, and the divisor that we divided by is what the denominator is. And this same rule is going to apply. Whatever turns out on top for long division is going to go here. Whatever we're left with at the end down here as our remainder, right? That's our remainder, is going to go up here, and our divisor is going to go down here. We're going to use this same logic for the division of polynomials. Now let's take a look at our first example. Divide x squared plus 2x plus 4 by the quantity x minus 3. So we start with long division, same idea. We put x minus 3 on the outside. We put x squared plus 2x plus 4. And what we see is that we have an example similar to the last one. But for this part, here's what I want you to start thinking about. And this is the easiest way to do it. Think about your leading part of your divisor. And think about the leading part of the dividend. How many times, or what is missing up top rather, what can go up here when multiplied by this quantity to give you this quantity? Because remember, whatever we put up here, we have to multiply and then put here and subtract. Multiply, put here and subtract, like we did with long division a minute ago. So the question becomes, what goes up here so when it's multiplied by this number, you get the same thing as this, so that they'll cancel. And what we really want to think about is the fact that we can multiply simply by x up here. And when I take this x times this quantity, let's see what we get down here. So we have x times x is going to give me x squared. Then we have x times negative 3 gives you negative 3x. Now remember, with long division we have to subtract, so we're really subtracting this whole thing. So what we have here is x squared minus x squared. Well, that's just 0. That could be left alone. And then 2x minus negative 3x, which is really 2x plus 3x, or simply 5x. Now, we bring down our next number. Remember, the next number always gets brought down. So we bring down the 4. The 4 comes down. At this point in time, we have to say to ourselves, all right, now, what can go in this spot right here so that when this number is multiplied by this first part, it cancels with this? Well, it's clearly just going to be a 5. Okay, we want it to just be a 5 because, again, they're subtracting. So if we just simply put a 5 up here, we're going to see that when multiplied, this 5 times x gives you 5x. So this is going to become 5x. Then this 5 times negative 3 gives you negative 15. And again, we are subtracting this quantity. So when subtracted, we have 5x minus 5x. That drops off conveniently. And then we have 4 minus negative 15, which is simply going to be 19. Now, when you get to the stage where the thing that you're looking at, or the thing that you're going to divide into, in this case 19, has a degree that's less than the divisor, you stop, because you can't divide this into here anymore. There's nothing that you can multiply here by to get you to get rid of this or cancel. So what we have to remember is to put a positive sign up here, because we really used a positive 5 there. Okay, and again, you can check this, because look, positive 5 times x gives you 5 times x, or 5x. We're subtracting because that's our rule of long division. So this tells me that the remainder is 19. Now, as a result, I can simply list my answer. Now, remember from the previous example, we said whatever the quotient is goes in as the whole number, or Now, we have to then think to ourselves, okay, the remainder became the numerator of the fraction, and the divisor before came the denominator. So this becomes plus 19 over x minus 3. So again, this was the numerical part earlier when we did the example that is a whole value, and the remainder, which really becomes the numerator of the fraction, goes here. The denominator of the fraction is always whatever the divisor was. Now, at this point in time, it might seem like, all right, how do I know that this is actually right? How do I actually figure out if this is right? Well, earlier, we divided 41 by 7, and we said that the result of this was going to be 5 6/7. And if you remember, what do we do to check? How do you always check that this goes back? Well, 7 times 5 is 35, plus 6 is 41. So remember from old arithmetic, 7 times 5 is 35, plus 6 gives me the 41. So you always multiply, so it becomes 41 over 7, which is 41 divided by 7. So we could do the same thing here. We could say to ourselves, well, let's check this. It was 7 times 5 plus this. So let's do x minus 3 times x plus 5 plus this quantity to check that we get back to the original answer, or the original dividend that we had here. So doing so, let's check here. So x minus 3 times x plus 5, again, x minus 3 times x plus 5 plus the 19. And that should give me this dividend that we had earlier. Let's check that we get that. This is going to become x squared plus 2x minus 15 plus 19, which becomes x squared plus 2x plus 4. So we go back and we take a look at our problem here. X squared plus 2x plus 4, well, there it is. X squared plus 2x plus 4. So the same way you would multiply these two and add the numerator to get this number here, we're going to do the same thing earlier. We take this quantity, whatever it is, times this quantity, and add this quantity to it to check that our answer is indeed correct. For the second example, we're going to take a look at where we have a quadratic being divided by a binomial again. The quadratic's leading coefficient, though, is 2 this time. And we might notice something about the result of this one that's a little bit different from the last one. The 2 has no effect on the problem, really, except it just changes what our answer is going to be up top. So remember, the first thing we start with is what value can go here. So when it's multiplied by this quantity, it gives me whatever this quantity is here. And this is simply going to be a 2x. Let's go ahead and put a 2x in up there. And now when I multiply 2x times x, it gives me 2x squared, which is exactly what I desired, the same number. And then I take the 2x and multiply it by the 1, which gives me just simply 2x. Remembering, though, that I need to subtract this quantity. Okay, I need to subtract that quantity. 2x minus 2x is 0. Negative x minus 2x is negative 3x. Next, we're going to bring down the negative 3. Remember to carry down this negative sign here. Then we have to say to ourselves, what quantity will go up here? So when it's multiplied by this x, it's the same thing as this. Well, it's got to be negative 3. If a negative 3 goes here, it becomes negative 3 times x, which is negative 3x. So let's choose negative 3 for this value up here. And then again, we're going to multiply it by this, and we're going to multiply it by this, putting those right here. So negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. And remember, we're subtracting this. Well, what do you notice? It's something minus itself. Negative 3x minus 3 minus negative 3x minus 3, which is just 0. Okay, you're going to see that these both cancel. Negative 3x minus negative 3x is 0. Negative 3 minus negative 3 is 0. So that tells me the remainder is 0. Well, that's interesting. If the remainder is 0, the answer for this is going to be just 2x minus 3 plus the remainder, but the remainder is 0, so it doesn't matter. Well, you might be asking yourself, how come this works? It works because when you divide this polynomial here by x plus 1 and you get an answer without a remainder, these two quantities must be the factors of this quantity. And let's check that that actually makes sense. Let's go ahead and FOIL. First is going to give me 2x squared, outer negative 3x, inner 2x, and last is going to give us negative 3. And what you get is 2x squared minus x minus 3, which is indeed the same thing as we had here. So our statement we can make is when the remainder is 0, the divisor is a factor of the dividend. Okay, the divisor is a factor of the dividend. In the third example, we're going to take a third order polynomial and divide it by a second order polynomial. Now, we haven't had one of these yet, so this is going to be a little bit different, but the idea is the same. One thing you should note, though, is that there's a missing term here. There's no x squared term. It's x cubed, x, and then a constant. Noticing, by the way, that these have all been in order all day. They've been in order. So when we do this, we should remember to think about a placeholder for that term that's missing. So we're dividing x squared plus 3x minus 5 into this cubic polynomial. 3x cubed plus 0x squared plus 2x minus 4. Now, the 0x squared needs to be there because we have a placeholder for it, and it's going to come out and play now. If you don't do it, there are ways to get it correct, but it's there is a lot of room for error. Now, let's start by saying to ourselves, what can go at this spot so when multiplied by this, it gives you the same thing? And it might not be obvious right away, but this is x squared and this is x cubed, so I definitely need an x up here. There's definitely got to be an x up top somewhere. But I also want to get rid of that 3, so why don't I also just make it 3x? Now, if I multiply this 3x by all of these terms, like we're supposed to, by all of them again, and list them below, I'm going to get 3x cubed plus 9x squared minus 15x. And notice the 0x squared comes into play. It's a placeholder because now we're going to have a quantity there. If we didn't have that there, it would have seemed like they weren't lined up correctly. Subtracting down, 3x cubed minus 3x cubed is 0. 0x squared minus 9x is minus 9x squared is negative 9x squared. 2x minus negative 15x is like 2x plus 15x, or simply 17x. Next, we have to take the negative 4 and carry it down. So carrying down the negative 4, now we have this quadratic. And the question then becomes, alright, what quantity should go up here now, in the next spot, right? So when multiplied by this quantity, it gives me the same thing as down here. So I need to put something up here that gives me the same thing as this. Well, negative 9 up here will make this negative 9 times x squared, which is what this is. So let's go ahead and put a negative 9 up here. And then we're going to distribute that negative 9 to all three of these terms, listing them below here. So negative 9 times x squared is negative 9x squared. Then we have the negative 9 times positive 3x is going to give me negative 27x. Then we have negative 9 times negative 5, and that is simply going to give me a positive 45. I have to remember that I'm subtracting this whole quantity, so I put subtraction symbol around it. These cancel to give you 0. Then we have 17x minus negative, which is really positive, so 17x plus 27x is 44x. Negative 4 minus 45 is negative 49. So it looks like there's my answer up there, and here's my remainder down here. So my result for a problem like this is going to say, alright, it's 3x minus 9 plus, now remember the remainder goes over the divisor. Okay, again, take a look. Here's your answer, your whole number component. That goes down here. Then the remainder goes in the numerator, and the divisor, again, goes in your denominator. So this is like a mixed fraction. This is like saying, this is like 5 and 2/3. This is like your whole number part, and this is your mixed fraction part. This one might be a little bit tougher to check, but if you do it again, you multiply this times this, and add this quantity, you'll get back to the dividend that you started with.